What's up guys, Shawnthebro here, and we're back for another episode of the fighting game tutorial series. And in this episode we're going to be going over cleaning up our animation blueprint further. So the last few episodes have been covering cleaning up the series in general. We've covered up our character blueprint, our character class significantly, our hitboxes, our camera, and some of our game mode and animation blueprint. We're going to be continuing with the animation blueprint for today's episode. And I'm just going to kind of pick and choose some things that I see in there that I have planned ahead of time, some of which would be dashes, how we apply those values, moving them out of the animation blueprint and into the character blueprint, cleaning them up, converting them to code, so on and so forth. I'll also be removing some unused logic and making it more adaptable. Let's leave this as a quick intro and get started. But before we do, if you want to get caught up in the entire series and check out everything that we've done to this point, from our hitboxes, our different attacks, our input buffer, and a whole lot more, I'll go ahead and link you to this playlist right here in the top right corner so you can check out how to do all of that. Alternatively, if you don't care about that and you only care about cleaning up your animation blueprint or having a clean animation blueprint for your character, that's perfectly fine. You don't have to follow the whole series to do this. But I do recommend you watch some of the other AnimBP cleanup episodes because I've gone over a lot of the topics in depth about why I think this new way is better, what makes them faster, more efficient, so on and so forth. So I'll link you to the first episode of cleaning up the animation blueprint in our fighting game tutorial series. Now with that out of the way, we can go ahead and get started. So this is a code and blueprint tutorial series. As I mentioned, I'm going to be cleaning up the animation blueprint. So we're going to be working in the blueprints, but we're also going to be converting a lot of the logic to code. So we'll be in the C++ logic today as well. Starting out, let's go to our animation blueprint, which we can get to blueprints, AnimBPs, and we can go to any or all of our characters. For me, the mutant AnimBP with root motion is the one I'm focusing on. And this first section where I come in here is the first thing I want to focus on today. This is called apply forward dash. So this is an anim notify, and if we go to our state machine, I know this is a lot to look at, but I know where they're at because these dashes are actually commands in our command list. We have dashes based on pressing forward twice or back twice. And we also have the ability to have the character run or roll as well. It doesn't have to be a dash. But for today's episode, we're focusing on the dashes and the forces associated with them. So if we go into command 7 dash forward here, we see we're playing our mutant forward dash animation. When we come in here, we have an anim notify, but that's actually not the one we want. So let's come back out and click on the state itself. And we see that the apply forward dash is done here. So when we enter this state, we're fully blended into our dashing animation. Then we were applying our dash movement or our dash forces. But these forces could be handled a little bit more elegantly in my opinion. So first of all, doing the actual dash logic in the AnimBP doesn't feel right to me. It makes sense to trigger it from the animation blueprint if we decide to do that, especially if we want to trigger these forces at a certain part of the animation, because we may not want to trigger them right away. But I do believe that the actual dash logic should be based on the character itself and in the character class. And it's not just the forward dash. If we go back to the state machine again and go to our command 8 here, the dash backward, you can see that we have the mutant backward dash here, which plays the backward dash animation. And if we come out here to the state itself on dash backward, you'll see that we apply backward dash. It's basically the same thing, but we apply forces in the opposite direction. This event is right here. Both of these can easily be converted to code, and if we want, we can consolidate it into one function. It could be good to leave them as separate functions if you want to have different behavior between the forward and backward dash. If it's just the direction, that can easily be handled in the same function. So let's go ahead and convert this to code. So first things first, I'm going to go to my code and I'm going to go to my fighter template character.h or my base character.h. I'm going to scroll down to where I want to make this function, and it doesn't really matter, but I'll put it somewhere that kind of makes sense here. We'll keep it public so we can call it from the animation blueprint. We can just put it under successful taunt here. That's perfectly fine. Perform a dash forward or backward, and that's actually good enough because that's really what we're going to be doing. We're going to be applying the dash forces or performing other dash logic. There could be other things you want to do with the dash, like playing visual effects, sound effects, whatever. We do want to make this U-function blueprint callable because the animation blueprint is going to call it. We'll still leave that part in, and to do this, we need to make this U-function blueprint callable. This is where we make our actual function, so we'll say void perform dash. So I'm going to change the name a little bit. But if we go back to these events, they don't have any parameters. We're just using our forward dash distance, which already exists within our character, and if they're facing right or not to determine which way to launch them based on the type of dash that they performed. And same with backward dash. It does not have any additional parameters. It has our backward dash distance and if we're facing right or not. So these are both things that we can handle without any parameters in here, but I'm going to add a parameter for if we're facing left or right. We also have the 3D fighter, which we are supporting, and I don't typically do 3D fighter logic in the fighter series as to keep that separate. Keep in mind that you may not just want to do forward or backward. You may want to do forward, backward, or 3D, we can say, which could still be forward or backward, but it may not be as simple as just determining what direction they're facing. It may take the actor's forward vector and move based on that. So we can just say or other, actually. I think that will make sense. And in this case, what we will do is just have a Boolean for if it's forward or backward. So bool is forward dash. If it's a forward dash, we'll apply the forward dash movement. If this is false, we will apply the backward dash movement. Simple enough. Now, when we're ready, we can go ahead and go to the fighter template character.cpp, and I'll go below my successful taunt function, which is where we made it in the header file. So Control F, successful taunt to find the function, or just scroll down until you get to it. And after this, we can go here, void a fighter template character, : perform dash. And in here, we have a Boolean, bool is forward dash. Now, we don't need to use this yet. Both of the events or the functions are exactly the same. We check to see if the character is facing right or not. And then based on that, we apply the movement in the corresponding direction. If is facing right. So if we're facing right, it's what it sounds like. The character is looking to the right. So if the character is looking to the right, a forward dash would be moving to the right. A backward dash would be moving to the left. If the character is not facing right, that means they're facing left. And if they're facing left, then a forward dash is to the left and a backward dash is to the right. So if is facing right, we are going to call the launch character function, which is how we're handling our dashes right now. This will have to change when we get into rollback, and this is something we're going to be covering with all of our launch characters. So we will apply our own forces, but when we do that, it's going to be the exact same method. We're still going to be moving the character that same amount. We're just not going to be calling this specific function. So I'll keep this for now. It will be an easy change later. But first things first, we need to call this function. So launch character. And here, we have to pass it the given velocity that we want to launch them based off of the values we set in the character class. So the X and Z velocity for a dash are 0. We're not moving them forward or away from the camera, and we're not moving them up or down. We're only moving them toward or away from our opponent. So this is perfectly fine, but we can't really do this if we want to have this in one function without checking our is forward dash. So after we check if we're facing right, we add another if in here, if is forward dash. Then we'll handle all of our cases. So if it's a forward dash, we're going to launch the character this way. Else, if it's not a forward dash, we're going to launch the character this way. And if we're not facing right, that means we're facing left. We come in here, and then we have to determine if it's a forward dash or not and launch the character based off of that. And you could consolidate this a little bit if you want, but I think this makes it very easy to determine what's going on. And so I like setting it up this way. So basically, if we're facing right and it's a forward dash, we know we want to move the character to the right. In our blueprint example, we can see that just means using our forward dash distance on the launch velocity y here. Launch character takes in an f vector as its first parameter. So we can just make an f vector, and it can be 0.0f for the x. The y will be our forward dash distance, and 0.0f for the z. Then we have to determine if we want to override x and y movement or forces and override z movement and forces on our character. So in the blueprint, we override the xy forces because the velocity that we're applying is on the y-axis. The z we're not applying anything to, so we don't care about changing it or overriding it. So we go into the code and we can say true for the xy forces and false for the z forces. So if we're facing right and we're not performing a forward dash, this means we're performing a backward dash, which would be backward. So we're going to make an f vector of 0.0f on the x, forward dash distance times -1.0f, and then z is 0.0f. Same thing here. We don't want to override the z movement, but we do want to override the x and y forces. So we're going to say true for the first parameter and false for the second. Now, if we're not facing right and it is a forward dash, we're going to launch them to the left. That means we're going to take this line here and replace this one with it. And then if we're not facing right, we're facing left. And if we're facing left and we're not dashing forward, we're dashing back, which means we're dashing to the right, which is this launch character. So now we've successfully converted both of these events into one function and changed them from blueprints to code. If you want, you could consolidate it by checking both of these booleans at the same time. For example, you could check is facing right and is forward dash, or not is facing right and not is forward dash, and just call launch character with the positive forces, else call it on the negative forces. And if you want to see this in action, I can show you. Basically, if we just check is facing right and is forward dash, and we can put this in parentheses because this is one conditional that we need to evaluate, or we can put these in parentheses, not is facing right and not is forward dash. Both of these are going to result in a positive dash or dash to the right, which means we can put this launch character in right here. Else, if we don't meet these conditions, we can simply do the backward dash. So you have a few different methods here. This one is a little bit bigger and some repeated code, but it's probably easier to understand. Then we have the condensed version here, which is less repeated code, but perhaps a little bit harder to understand. So it's up to you. Whatever route you want to go is fine. This is nice and neat. So if you understand this, that's perfectly good with me. Of course, we will test it and make sure it's still working. But when we're ready, we can go ahead and stop the editor and replay again after building. Now the editor is back open, so we can go back into our Mutant AnimBP root motion. We can go back to the event graph, and we can go to our two events that we had here and disconnect this logic. Alt left click or just right click on it and break the execution line. Then we can use our character reference, which is the owner of this animation blueprint. I already have it here in my logic, but if you need to get it, it is a variable that we set up in our animation blueprint. It is of our base character BP, and we assigned it earlier in the AnimBP when we're setting up after initializing the animation. So at this point, we need to use our character blueprint, or character reference here, and call our function that we made, which is going to be perform dash. And we need to say it is a forward dash if we're applying forward dash. So we can still have two separate events in the AnimBP and just set the parameter based on that. So I'll leave it right here for now until we verify that it's working, but this is all you will really need to do for this. And for the apply backward dash, we're going to basically do the same thing. We're going to get our character reference, but this time what we're going to do is drag off of this, call perform dash, and we're going to leave is forward dash as false. There we go. So we can compile and save, and let's test out our dashing logic. So here we go, we're in our game, and I can dash backward, and it applies the momentum backward. I actually have the run connected right now, which I need to change out so we can test our dash logic, but our backward dash is correct, and we can jump to the other side here and dash backward, and we can see that the forces are being applied correctly. So the forward run, or forward dash, will probably work when we remove forward run, but let's go ahead and just make sure that we change that out so we're positive. To change this out, whether we're dashing, running, or rolling, we can go to our data table for our character. If we go to blueprints, library BP's mutant command data, and here's where all of our commands are. So we can go to forward dash, and we'll see that forward dash results in the running forward state. So when we double tap forward, we go to running forward, which is going to put us in the running forward animation. If we change this to dashing forward, we will then be able to perform our dash. So when we come back into our game now, we should be able to dash forward. And we can. Let's make sure when we jump to the other side, this also works. So dashing backward, dashing forward. And we can see it works. Now player 2 does have some issues with dashing and running, which is known. So when you try and do it, it doesn't play the animation. This is something we're going to be fixing, so don't worry about that. But player 1 should be able to do it on both sides, and switching should always work. Once we're positive that this works, you can change it back to running forward if you'd like to keep it that way. And then at that point, we can close out of this, and we can go back to our animation blueprint, go to the event graph, and go to these events, and we can remove all of this logic in here except our new function call. So apply forward dash now looks like this. Cleaned up significantly. And then apply backward dash is going to do the same thing. You can get rid of all these nodes. And here you go. Looks good. Let's move these closer together. And problem solved. Much cleaner, much easier to use, and now our character controls the logic, not the animation blueprint. So this is significantly better. I hope you enjoyed cleaning up your dash logic, converting it to code, making it more efficient and more adaptable. If you did, please subscribe and consider checking out the Patreon, YouTube membership, and Discord subscriptions to help benefit myself and the channel. I really appreciate it. I want to give a huge shout out to everyone who already has supported it, so thank you so much. If you ran into any problems following this tutorial or any of my tutorials, feel free to join the Discord community. There is a link in the description, and I would be happy to help you out. Thank you so much for watching. I'm Shawnthebro, and I'll see you in the next one. Goodbye, guys.